Much more sophisticated than their analog counterparts of the past, digital multimeters have changed into a highly specialized device, engineered specifically for testing a wide variety of equipment in both commercial and private uses.
As the name suggests, digital multimeters combine convenience with multiple functions. A digital multimeter works by converting a physical signal, such as voltage, current, or resistance, into a numeric display. Standard settings for most digital multimeters include measurements for voltage, current, and resistance. In addition, a multimeter should be capable of reading both direct DC current and alternating current or AC values. An automobile battery is an example of a DC device, and a television is an example of an AC device.
Today, modern digital multimeters are designed to be rugged and easy to use.
The meter consists of a marked display, below which is a large selector switch. This switch determines the mode of the operation of the meter. By rotating the knob, you can change the operation of this multimeter from a voltmeter to an ammeter or to an ohm meter.
Before using a digital multimeter to perform a test, first decide what's being tested for and generally what type of results are expected. To find the correct voltage value, select the proper range for the test.
For example, when looking for a 12-volt result, the meter range must be set higher than 12 volts. If the 20-volt range is selected, a reasonably accurate value will be shown. However, if too low a range is selected, the meter will not be able to read the 12-volt value. Or if the 200-volt range is selected, it will show a less accurate reading. Many multimeters have an auto range feature that will automatically select the proper range. These meters may also allow you to override this feature and let you manually select a range for yourself.
With a digital multimeter, checking for AC or DC volts is possible.
In measuring voltage in a residential wall socket, the meter should be set to read AC volts, and the value should be between 115 and 122 volts AC. If testing a battery, the meter will be set to read DC voltage at the appropriate range, unless the meter is an auto-ranging meter. When measuring an unknown voltage, always select the highest range and work down to the proper range. In this example, a 9-volt battery is being tested, so the proper setting should be 20 volts DC. Touch the black lead of the meter to the negative terminal of the battery and the red lead of the meter to the positive terminal. The meter should now read 9 volts DC.
In order to use a digital multimeter to test a circuit for resistance, it's important to remember that the circuit must be de-energized.
Rotate the selector switch on the meter so that it reads the highest resistance range. Connect the red and black leads of the meter to both sides of the component being tested. Rotate your selector switch to lower resistance values until the greatest accuracy is achieved. If you're using an auto-ranging meter, this will be done for you automatically. Look carefully at the display. If there's a K displayed after the reading, multiply the reading by 1,000. If there is an M displayed after the reading, multiply the value by 1,000,000.
Because of the way resistors are manufactured, the actual resistance value may vary slightly from the labeled value.
In this circuit, the measured value of the 10-ohm resistor is 10.2 ohms.
Another use of the ohms function on a digital multimeter is to test for continuity. If a circuit has a path through which electricity can flow, it is said to have continuity, and the circuit is closed. If, on the other hand, current cannot flow because of extremely high resistance or a break, the circuit is said to be open or to have no continuity.
When the switch is open, no current is allowed to flow from the battery through the switch to the resistor.
In order for a multimeter to measure current flow in a circuit, it must be placed in line with the resistor and the switch.
The connections to the multimeter may need to be moved to the 10-amp terminal if the current being measured is going to be greater than 200 milliamps. Break into the circuit by removing a wire and putting the meter in series with the current. Place the red lead of the meter to the most positive connection in the circuit. place the black lead of the meter to the other connection in the circuit. Change the selector knob to the proper current range. Close the switch and read the current. If a minus sign is indicated in the display, reverse the leads. If an auto-ranging meter is not being used, decrease the range of the meter until the most accurate reading is achieved. If a small MA is displayed, then the reading must be divided by 1000 or interpreted as milliamps.